Okay, let's get started on section 6. Finally, we get away from something that's geometric. We've been doing geometric measures for the last couple of weeks. We've done area, volume in a couple of different ways. We did arc length and we did surface area. Now, time for something else, and actually time for something awfully easy. It was kind of nice to have an easy section thrown into the works here. We've had a bunch of tough ones lately, and we've got a couple of tough ones coming up. So it'll be good to have an easy one here. So expect this one to be much simpler than what we have been doing. Okay, but anyway, what we're going to be looking at this time, guys, is what's called average value of a function. All right, so the idea is, I'm just going to draw a little miniature picture up in the corner here. If we were to have some function doing whatever you want it to do, maybe it's going up for a while, then down, then back up, what we're going to do is we're going to look over an interval, and we usually, like always, call that a to b. All right, and what we might do is we might want to look at the average value of that function over some interval. Now remember, when we say value of a function, we're talking about the y values. So what we're doing essentially is taking an infinite number of y values. Let me switch to red so these stick out a little bit better. So we're taking this y value and this y value and this y value and this one 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 and this one. We're taking an infinite number of y values and averaging those out. Okay? It might sound like it's going to be something relatively complicated, but it really isn't. Look below. It just simply says if f is continuous and differentiable on a to b, meaning on the interval from a to b, then the average value for the function is, and we use this notation, f for the name of the function, and then avg or ave, depending on what textbook you look in, for average. Those, the avg here, let me circle it in red. This is meant to be a subscript. I'm not sure if it looks very good on your screen, but that's meant to be a subscript. So it's supposed to be f sub average is going to be equal to 1 over b minus a times the definite integral from a to b of f of x dx. Now if I select my laser pointer here, this whole definite integral is always equivalent to what, guys? Definite integral from a to b of some function is going to be equal to or equivalent to the net signed area. So what we're doing is we're taking the net signed area and essentially just dividing by b minus a. But if you look back up to the picture, what's b minus a always going to be? Just the length of the interval. So it's a net signed area divided by the length of the interval. And it's as simple as that. That's all there is to it. So to look at a few examples, we can actually buzz through several pretty darn fast. Here's a function, and with that third term, it's not a real obvious function, but here's a function on an interval from 1 to 4, and what I would ask you guys to do is find the average value of that function. And it's simply just going to be 1 over b minus a, so in this case, 4 minus 1, times the definite integral from 1 to 4 of that function. Okay, so what we're going to have is just a constant. In this case, 4 minus 1 is 3. We're just going to have a constant in front of the integral. Okay, and now I just expect you guys to integrate x squared by adding 1 dividing by the new, integrate x by adding 1 dividing by, the new, and integrate 1 over x. Please be careful, that's one of your basic rules, right? That's one of your basic rules. It's like number 3 or 4, something like that. The integral of 1 over x is the ln of x. And then we'll just simply be f-ticking from 4 down to 1. I'm just going to put the 1/3 in front so we only have to multiply by that one time. And now everywhere I see an x, I'm just going to put in 4. So 4 to the third over 3 plus 4 squared over 2 plus the ln of 4 minus, now everywhere you see an x, put in 1 to the third over 3 plus 1 squared over 2 plus the ln of 1. All right? Now, with the exception of one term, this would be real easy to simplify. The ln of 1 at the end is 0. You could use your calculator to remind you of that. But the only term that makes this difficult at all is the ln of 4, because that doesn't turn out very nice. So what I'm going to choose to do on this one, just to get you a feel for this, guys, is I'm going to give you a decimal approximation. All right, so I'm going to start by adding 64 thirds plus 8 plus the ln of 4. And as a decimal, we get 30.72. Then I'm going to add 1/3 plus 1/2 plus the ln of 1, but again, that's 0, so you could just skip that step if you preferred. And what we get is 0.83. I just need the tiniest bit more room. So when I put the two terms together inside the brackets, 30.72 minus 0.83 is 29.89. And when I multiply that by 1/3, let's see what we end up with, about 9.96. So approximately, and I approximated on a couple of these steps, I should use approximately equals to. So the average value of that function on the interval from 1 to 4 would be 9.96. If we took an infinite number of y values on that interval, added them together and divided by how many, we would get an average of 9.96. Okay? So feel free to pause the videos if you want to take a harder look at any one of the problems, but here's another example. Let me make this one a hair bigger. There we go. And again, what we're going to do is find the average value of the function. Just for the heck of it, I call this one h. So we'd have the average of h being 1 over b minus a. So in this case, that's 1 over 4 minus 2 times the definite integral from 2 to 4 of the function 1 over x times the square root of x squared minus 1 dx. Okay? Now, of course, 4 minus 2 out front just gives us the width of the interval. So essentially, we're just dividing by 2. But then what we have to do is integrate, excuse me, we have to integrate 1 over x times the square root of x squared minus 1. And your first thought's probably we got to do some sort of u substitution, take the derivative of the substitution and all of that. But in this case, we don't, because what I'm giving you for an integral, 1 over x times the square root of x squared minus 1, is what actually one of your basic rules. It's just not one that you guys recognize very well because, excuse me, because we don't use these a whole lot. But it is one of your basic rules, and off the top of my head, I don't remember what number it is. It's probably in the late teens somewhere, so 15, 16, 17, one of those rules. But what it does match up exactly to is the rule for the inverse secant of a function. All right? So it looked like it was going to be a nasty integral to do, but it actually fits one of our basic rules, so it's actually very, very simple. So then we can go directly to f-tick. We just have to replace x with 4 minus, and replace x, whoops, that's kind of ugly. Let me make that a little bit nicer. And then replace x with 2. Okay? And I'll get to a decimal answer on this one for everybody. So we need the inverse secant of 4. All right, so let me punch that out for, sorry, for everybody. Oop, and I have a typo here. I didn't see it right away. It's supposed to be secant. Let me choose my laser pointer. I wrote secant here. That's what I'm supposed to have. But I have a typo right here. So I've got to deluxe eraser that fella. There we go, and correct that, so that's not messed up. So that's supposed to be a secant as well. Okay, there we go. Alrighty, guys, so let's see. Alright, so I just need that. Alright, so what I need then is the inverse secant of 4. So I just need to punch that out. Alrighty, so inverse secant of, and I get about 1.32 there. And then I need the inverse secant of 2, which is about 1, oh gosh, that's about 1.05. 1.05. Just shrink this up slightly so I can get my last 2 steps in for everybody. Whoop, that didn't work so well. Shrink that up just a hair. There we go. So I'll subtract 1.32 minus 1.05 is 0.27. and multiply that by 1/2, and if I'm punching okay in my head, I get 0.135. So the average value of that function would be about 0.135. Okay, alrighty. And I've got one more basic example to jog through, and then we'll get to an application. All right, so again, the average value of this function is going to be 1 over the length of the interval, so b minus a, times the definite integral, so the net signed area. So in this case, the net signed area from pi over 2 to 3 pi over 4 of negative cosecant of x times cotangent of x dx. Okay, 3 pi over 4 minus pi over 2 is going to be 1 pi over 4. And then again, you might be a little bit worried about the integral, but again, it fits one of our basic rules. I picked a few that just fit our basic rules. If you look under your basic trig rules, we have one that says the integral of negative cosecant times cotangent is going to be equal to cosecant. Okay? So we just simply have to f-tick. But let's take care of this fraction first. 1 over pi over 4 is the same as 4 over pi, just taking a reciprocal. And then f-tick, so I'll have the cosecant of 3 pi over 4 minus the cosecant of pi over 2. All right? Again, none of these turn out really great. Actually, I guess they're not terrible, but with the 4 over pi, they're not the nicest things. Let me see if I can remember these without a trig sheet in front of me. The cosecant of 3 pi over 4, that's going to be the square root of 2, if I remember correctly. The cosecant of pi over 2 is going to be 1. And then again, it doesn't look very nice, so I'll just get a decimal value for everybody. So I'll have the square root of 2 minus 1 times 4 over pi times 4 divided by pi. And if I punched okay, guys, I ended up at 0.53. So the average value of r is 0.53. All right. And finally, just to finish off, I've got one application of where you might use average value. Okay, so here it is. We have a new car cost of $36,000. I have no idea what that buys you, but if you guys buy yourself a brand new car for graduation and it costs $36,000. I picked a car that has a depreciation rate of 12% per year. So just going back to pre-calc, I created an equation. Let me highlight it in red here. I created an equation that would give you the value of the car after any number of years t. All right? So it's 36,000 times e raised to the negative 0.12t power. Therefore, what would be the value at time equals 0? Well, you know the answer because the new car cost was 36 grand. But just to show you the formula works, this would be equal to 36,000 times e to the negative 0.12 times 0 power. Now, of course, negative 0.12 times 0 is 0. What's anything raised to the 0 power? 1. So 36,000 times 1 is $36,000. So, of course, no surprise, that just shows you the equation works when time is equal to 0. My second question, what's the value of the car after 10 years? Well, that would then be 36,000 times e raised to the negative 0.12 times 10 power. This time when you multiply the numbers in the exponent, you don't get 0. What you get instead is negative 1.2. And then e raised to the negative 1.2 is, I'm going to punch that fella out, there it is, negative 1.2 is 0.301. And when I multiply that by 36 grand, the value of my car after 10 years then, according to this model, would be $10,842. All right, that would be the value after 10 years of driving this, normal wear and tear. Okay, but the last question I'm going to ask you is, what's the average value for the first 10 years of the car? So if we consider the value to be V, we'd be looking for the average. And all we simply have to do then is divide by the length of the interval, so we're going to have it over 10 years. Okay? And so we'll integrate then from 0 to 10 the value of the car, 36,000 times e raised to the negative 0.12 t power. Okay? So here we go. I'm going to do some simplifying. 10 minus 0 is 10, so I'd have 1/10. But then I'm also going to factor the 36,000 out front, just to get it out of our way. And all I'd be left with then is e raised to the negative 0.12 t power. Now I can't integrate that as is, so I have to use a u substitution. I have to replace negative 0.12 t with u. But anytime we ever make a u substitution, we have to take the derivative of the substitution. So the derivative of u is 1 du, and the derivative of negative 0.12 t is negative 0.12 dt. Now we don't have an extra negative 0.12 laying around, so I'll have to divide that to the other side. So I'll be able to replace dt with negative 0.12 du. And so my substitution then becomes 36,000 divided by 10 times the integral of, instead of e to the negative 0.12 t, it'll be e to the u. And instead of dt, let me circle that up in red. Instead of dt, I'm going to replace that then with, let me switch back to black. Then I'm going to replace that with negative 1 over 0.12 du. And of course, you guys just saw what I did. I pulled the number out in front of the integral. And since we're doing a u substitution with a definite integral, we can do a change of variable. Again, let me switch colors. So I can take the original limit of integration 0 and put it in for t. So negative 0.12 times 0 is 0. And then I could put in 10 for t. And u would be equal to negative 0.12 times 10, which is negative 1.2. And now that I've done a change of variable, I don't need to switch back to t's when I f-tick. Okay? Now I'm just going to help myself out by computing this whole value. So 36,000 divided by 10, of course, is 3,600. And then we've got to make that fella, negative, because we have this negative sign attached to the fraction. And then I've got to divide by 0.12. And if I punched okay, I think I did, I've got 30,000. All right, so that's all of the numbers put together out front. Now let's just integrate e to the u, but that's easy, that remains e to the u. And then we're just going to have to f-tick from negative 1.2 down to 0. Okay, so here comes the f-tick, e raised to the negative 1.2 power minus e raised to the 0 power. And I'm just going to do the computation inside. E raised to the negative 1.2 power is 0.301. Anything raised to the 0 power is 1. And then when I subtract and multiply, notice the number inside is going to be negative. So two negatives multiplied together get a positive value. So I end up with 0.301 minus 1 times negative 30,000. And what I'd end up with then for an average value over the first 10 years of the car is an average value of $20,970. And I'm going to get rid of that positive sign because it just looks goofy with the dollar sign in front of it. Okay? So the average value of the car over the first 10 years, and of course you guys could pick any number of years, 5 years or 15 years, whatever you want, we could find the average value. Okay? So hopefully the problems in the assignment won't be too bad. They're meant to be not very difficult. Please notice there's a couple of special rules, like 9 and 10 require a couple of special rules from your note card. Okay? But have fun with those. Let me know if you have any questions. I'll try to help you out. Okay? Have a good day. Bye.